All right. Well, hello. Welcome back to ArmanisMath. This is lecture number 13. And we are going to talk about trig functions of given points, such as x comma y. So if you're given a point, x comma y, how do you find the trig function for that? Meaning, how do you find the cosine, the sine, and the tangent? For those who wanted to go a little bit further, obviously we are, you could do the reciprocal of these and get the secant, cosecant, and cotangent. But for most of us, we're going to just focus on the cosine, sine, and tangent, right? This is the goal for today. I am so thrilled to see you today. You guys are awesome. Okay, here we go. The warm-up, as usual, to get our brain in the game and just get us dialed in. Here is the warm-up. It says, plot the following points for number 1 and 2. So, as we always do, we give ourselves a timer for this. And I'll be generous today, so I'm probably going to give you a minute and a half. Oh, come on. Okay, I'll give you 2 minutes. Obviously, I'm going to stop it before then. This is for those who are watching afterwards. So here's a couple minutes for this. Most likely I'm going to stop in about a minute and then come back to you. Do use a graph paper. It's probably easier. What we're doing right now is doing the warm-up before the lesson. Okay, once you get things figured out, if you would help us in the comments, keep them appropriate. This is obviously just beyond us, so this comment is visible. All right, I'm gonna pause here and then start to graph. So 2, 3. So let me get myself a I'm gonna get myself a graph paper, and I'll start 2, 3. Let me say that this is my x-axis. This is my y-axis. And can somebody give me the point in the comment, please? Can somebody put the point? What's the point we're trying to graph here? Does anybody remember? Well, what's the first point that we need to graph? I think it was 2, 3, if I recall. Okay, so x is 2, y is 3, and we're trying to graph this or plot this point. So basically, I have to come and count is 1 and 2 and 3. I'm sorry, 1 and 2, I should say, and then going up 1, excuse me, 2 and 3. This is my point, 2, 3. X and then the y. I just want to add just a little bit of information here. So let's say that I'm not going to ask you to do it, but just a thought. This is 2, obviously. This distance is 2. This distance up here is, I went up 3. So this is 3. This is 2 for the x. This is 3 for the y. What do you think is this guy here? I'm not going to ask you to do it. I'm just saying. Okay. Second point. We need to graph negative 4, 4. Okay, so right here, I'm going to put negative 4, 4. And let's see if we could graph 4, 4. Okay. So over here. And I'm gonna go all the way down to negative 1, 2, 3, and 4. I'm here, negative 4. And then it says 4, so I'm trying to plot negative 4 comma 4, which is, again, this is the x, this is the y. And excuse me, oops. Negative 4 comma 4, and that would come all the way up to here is 1 and 2. I'm here. I'm at this point. So this is negative 4 comma 4. I'm not going to ask you to do it. I'm just saying, what if I want this length here? How much would that be? Pretty interesting. So we got a 4 down here. That's a 4. 4. This guy's 4. How much would this be? What can I use to get this one? Okay. We're not going to answer that question yet. Find this value here. Excuse me. Find this value here. One second. Not sure what's wrong with my throat today, but pardon me. Pardon me. Pardon me. Pardon me. Okay, 3 squared is how much? You could help me with the, you could help me in the comments. That would be great. What would be this this value that we're looking for? What could be that value that we're looking for there? I have the square root of 3 squared. And I've got 3 squared, and then we have negative 4. Let's see if we could work this out. This is basically, they're saying that I've got 9 plus the 16. 9 plus 16 is how much? 9 plus 16 is how much? Interesting. 10 plus 16 is 26. So take 1, that's 25, which is just a 5. Okay. Tangent pi over 4. Probably need a cough drop here. I'm okay, guys. I'm okay. Just tangent pi over 4. What is pi over 4 anyway? Everybody know what's pi over 4? What is pi over 4? Got a couple eyes here back and forth between the comments and the 2 screens that I have. What's pi over 4, do you think? You take the pi divided by 4. 4 pieces. That's 2. Oh, that's not exactly. Piece. 1 piece, 1 piece, 2 pieces, 3 pieces, 4 pieces of the pi. The pi is 180. You slide that into 4 pieces. Well, that means you got a quarter of the pi. Quarter of the pi, quarter. So this is going to be a 45. So basically they're asking what is tangent 45. And tangent 45, if you remember from a couple lectures ago, tangent 45 is going to be 1. Okay. I know there's a delay, obviously, between the streaming, but if you could, as much as possible, just follow along with the comments. Okay, it says here the objective. You'll be able to find trigonometric functions of given x and y points on the rectangular coordinates. Rectangular coordinates or Cartesian coordinates are the same. And what we're trying to find today is, again, I give you a point, and we're trying to find the trig functions. Basically, they're trying to find the cosine, sine, tangent of a point. And what we're talking about today is a little bit beyond the unit circle. So, for example, if I were to graph a unit circle, say I want to graph a unit circle, and the unit circle, I'm just saying, let's say that we're somewhere here, for example. And we are jolly and happy in the unit circle because we know the values all around. But what if the point is actually beyond the unit circle? For example, what if the point is somewhere here? So this is the unit circle of radius 1. This point is up here, all the way up here. Let's say this is 3, 3. How would you find the x and y value for 3, 3? That's a point beyond the unit circle. So you're stretching your arm beyond the unit circle. No longer 1 as in the unit circle of the radius. Now you're going beyond the unit circle, trying to reach out to that value all the way up there. Maybe 3, 3, maybe negative 2, 5, maybe negative 4, square root of 3, something. But it's beyond the unit circle. So that's the goal for today. How do you find the trig functions for them? How do you find the trig functions for such points? And remember, the trig functions, these trig functions include cosine, includes the sine, and it also does include the tangent. Obviously, if you're doing, as we said, if you're doing like a little bit advanced, so cosine would be secant, and cosecant, and cotangent. How do you find these for a point that is beyond the unit circle? That's what we're going to talk about today, particularly the first 3. All right, so this is the goal. Here's one. We're coming back to this illustration here. Real-life applications for trig functions. For example, trig functions like sine and cosine are used to describe sound and light waves. And I believe this is a person who is praying somewhere, I guess. Looks like he's praying, like seeking God's help in times of trouble, like what we're doing now during this pandemic. And the ray of hope is coming towards, and there is scientifically methods that you actually could use the trig functions to help you find the waves for sound and also light. Okay, can you think of another example? Perhaps you could Google that and maybe help us on the comment if you'd like. Here's the first example. It says find trig functions of 3, 3 and the corresponding angle in the interval 0, 2 pi without a calculator. So first of all is I'm given a point and I'm asked from the point to find the trig function for that point. Basically they're asking for sine, cosine, tangent of that point. So how do you find that? Excuse me. Well, first of all, let me give you a preview. Number one, we've got to know that, I'm repeating because we did that before. We introduced that thought before, that every x is cosine, every y is sine, and every tangent is y over x. If you are in doubt, I'd probably check back a few lectures ago we set this up and we proved it, and we developed this concept here. So now if you're given a point such as 3, 3, you would know that you're talking about trig function just because of the point itself. There's a trig function behind it. This is, once again, this is x, this is y. Every x is cosine, every y is sine. So basically, from a point on a Cartesian coordinates, rectangular coordinates, you would know there is a trig behind it. So now comes the question, how do you find the r? Okay, so today I'm gonna add to this concept here just one more addition, and that is the following here. Follow along with me. This was true because in the unit circle, I'm gonna say this is in the unit circle. This is in the unit circle. But what if you want to go beyond that? Remember, the unit circle has like a radius of 1. So now you really have to develop this concept to add to that fact that r equals 1 for the unit circle. But what if r now is not gonna equal to 1? It's beyond 1, longer. It's a longer arm than 1. Well, then you have to account for this r. So basically, you're gonna take the exact same concept, but you have to add. So now your x, I should say, let's say cosine. So now cosine is gonna be your x divided by the r. Sine is gonna be your y divided by the r, radius. Tangent is going to be the y over x. That didn't change. Okay? So we just have to account for the r. If it's beyond the unit circle, you have to know what's the r. And let's look at the point. Let's take a look at the point. Do you think this point here is in the unit circle? Is this in the unit circle? No, because the unit circle has a radius of 1. So it's probably living somewhere. So if I were to graph this point, for example, I would probably go, if this is my unit circle, and let's say that I'm graphing the unit circle here, where would this point be? Well, come on, Armani. This point would be really far. I mean, this is like probably here, maybe here somewhere. So as you could tell, it's beyond the unit circle. It's really probably even further. It's here somewhere. 3, 3 is here somewhere. So this is the unit circle. This is unit 1. If you gave me this one here, I would probably know that it would like 1. Actually, it's not going to be 1. Less than that. Okay, so, but this is beyond the unit circle. So how do you get the trig functions for that point? How do you get the cosine, sine, and tangent for that point? That's what we're going to talk about today. Very easy. I just showed you how. So first of all, cosine is going to be equal to x over r. Sine is going to be y over r. Give myself more room here. Sine is going to be y over r. Tangent will be the y over x. Remember, we are trying to get trig functions, cosine, sine, and tangent, for a point that is beyond the unit circle. It's away, it's outside the unit circle. So we're no longer bound by the unit circle, radius of 1. Now you're looking beyond that. So the question now becomes, how do you find this r? How do you find this radius? Well, you actually use the Pythagorean theorem for that. And for example, if I want to find r here, what I'm going to say is to find r, I'm going to say r equals, I'm just using the Pythagorean theorem, by the way. R equals the square root of x squared plus y squared. Basically, I'm looking at the points here. So r is going to equal to square root of 3 squared plus 3 squared. 3 squared plus 3 squared, that's the 9 plus 9. That's the square root of 18, which is, by the way, 18 is 9 times 2, right? 18 is 9 times 2. So 9 is the perfect square, so I just have to circle that. You're always looking for the perfect, I should say, the biggest perfect square under the square root. So this is basically, you're saying this is the square root of 9 times 2. Square root of 9 is 3. 3 times 2. 3 square root of 2. Okay, so this is your r. R is this. Now I know my radius. I know this amount, by the way. That's this guy here. This is 3 square root of 2. Okay, so this would be the 3 and the 3. This is square root of 3, square root of 3, square root of 2. So now let's now go back and see how can I plug that into my cosine. So I know r. I'm running out of room, so I'm going to put r somewhere. Okay, I'm just going to highlight r and then put that somewhere because I'm running out of room. So I'm going to put r here somewhere. And r for me is going to be, again, r equals 3 square root of 2. Okay, I'll keep that in mind because I'm going to use it a lot. I'll go back here and try to erase a little bit. So I'm going to erase here. Okay. And now try to fill in this data here, fill in this information here. Okay, so back to this guy here. It says you're telling me that this is x, and x to me is 3. Remember, this is x and y, x and y, x and y here. This is x. So 3 divided by, that's the radius, 3 square root of 2. You cancel out the 3's. And that's going to give you 1 over square root of 2. And you rationalize that by multiply top and bottom, which will eventually give you what you're looking for, and that is square root of 2 over 2. So cosine equals that amount. Okay, cosine equals this amount. I'm going slow, the first example. Excuse me. Once you get the hang of it, we're going to go a little bit faster. Now let's go back and see what would I do for the second one. So y. Y again is going to equal to, the y is up here. I'm just using the fact y is here. See that? This is y and this is x. So y is 3, this is 3. Divided by my r, radius, square root of 2. Again, you just cancel things out. Chop, chop. And that's going to leave you with 1 over square root of 2, which again, you have to rationalize that. Square root of 2, square root of 2, and square root of 2 here. Come on. Square root of 2 here. And that should leave you with, again, square root of 2 over 2. Now keep in mind that there is something happening here. I've seen these numbers before. I've seen an angle that has a square root of 2 as a cosine. I've seen an angle that has square root of 2 over 2 as a sine. Okay, I think I know. I probably could guess what angle is that. Well, let me wait a little bit. Y over x. What's my y? 3. What's x? 3. So what's tangent? Excuse me. I'm not sure what's wrong with me today. Tangent is 1. So can you infer from what's given here? What is that angle that has, what's that angle that has a cosine of square root of 2 over 2, a sine of square root of 2 over 2, and a tangent of 1? What could that angle be? Focus, you guys, on the comments. Focus. What could this angle be? If it helps you, you could write it like this. You could say this is square root of 2 over 2, comma, square root of 2 over 2. What angle? Here we go. Here we go. I just got an answer here. In the comment, I got an answer. And theta is 45 degrees. That is very true. Theta is 45 degrees. So what was so special about today? Well, every day is so special. You are special. You're awesome. You're amazing. Yes, good looking and amazing. Intelligent. Dedicated. Same thing with a 45. Because the ratio doesn't change. Square root of 2 over 2, square root of 2 over 2. When you reduce things, this is what you get. This will have to be 45. This angle here will have to be 45. So we are talking about 45 here. 45 degrees. Where else could this happen, by the way? If you have an interval between 0 and 2 pi, this is 45. Where else could this happen? This also could happen here, by the way, if all students take calculus. Tangent is positive here, which will give you a 225. That's a possibility. But I really have to think a little bit hard here. Let me see if I have to think a little bit harder here, just a little bit, because if it happens that if I am in the third quadrant, does the point make any sense? Does 3, 3 belong to the third quadrant? The answer is no, it doesn't. So that's why you have to reject this possibility. It doesn't. It's not going to live here. 3, 3 does not live here. 3, 3 does not live here. If you gave me a point that is -3, -3, I would probably say, yeah, you're right. But not 3, 3. So that's why you have to reject this possibility. It is a possibility, but you got to reject it because that point that you were given does not live there. It doesn't. Okay. Excuse me. Let's do another one here. I'm gonna speed up a little bit. Okay. So this one says you have a -4, 4, and it's asking me to find the trig functions, cosine, sine, and tangent, and also find the corresponding angle. What angle does this point make? Well, I'm not too sure, but I could try to guess, to mathematically infer to see what's going on here. So let's say I have this guy here, and I have this one here, and you just gave me a point that actually lives somewhere -4, 4, -4. Remember, this is a unit circle. This is 1. So -4, 4 would be like whoa, somewhere here, like really, really far here. -4, 4. Okay, -4, 4 lives here somewhere. It does live here somewhere. Okay. -4. By the way, I just gonna have to label things. This is my X, this is the Y, and I know that I'm in the second quadrant just because of the setup here. Okay, so first thing first, I'm gonna try to find R, which is the square root of X plus Y squared. And in my case, I'm gonna just follow along here, and that's gonna be the square root of I've got a -4 squared plus 4 squared, and that's going to give me a 16. That's square root of 32, right? R equals square root of 32, and I know under the 32, if I branch this out, that's 16 times 2. 16 times 2, is that right? Yep. And I also would, since I got my biggest square, perfect square under that, then I'll just stop. So which is going to give me again a R equals square root of 16 times 2. Square root of 16 is 4. 4 square root of 2. R equals this amount. Okay, R equals this amount. So I got R. So from R, I'm going to go back and find my cosine, sine, and tangent. Cosine equals cosine of theta, obviously. Remember, I've just neglected to put theta, but there's a theta, there's an angle, cosine of the angle, equals x over r. And my answer, my x is going to be, it says here -4. R is going to be 4, square root of 2. I have to erase. Guys, I'm going to put the radius here. I'm going to put the radius down here and then just give myself more room. Okay, so R equals 4 square root of 2. Okay, I'm going to just put that here somewhere because I'm going to use it and I need more room, so I'm going to just have to erase stuff here. I got my R, and now I have to find x and y and z. I'm sorry, x and y and tangent. So if I'm following this through, I have a -4 divided by 4, where this is going to go away. Bleep, bleep. -1 over square root of 2. You rationalize. I'm not going to go through it again, but you do it, right? Square root of 2 over 2. And then that's going to give you negative square root of 2 over 2. Okay, that's the cosine. Sine is going to be the y over r. I know my y is just looking at the point here. This is x and this is y. Y is 4. Okay, so I'm going to say 4 divided by my radius. I found the radius to be 4 square root of 2. Well, that means I just have to, again, chop chop. And that's going to give you 1 over square root of 2. Pay attention to your signs, by the way. Which means you have to rationalize that. Rationalize that. Top and bottom. That should give us a square root of 2 over 2. Interesting. So there's something going on here. There is an angle that has a negative square root of 2 over 2. And a sine that has cosine. And there's a sine of square root of 2 over 2. Interesting. Okay. Tangent. Tangent of that angle is y over x. Y over x. Y over x. And my y is 4. X is -4. Well, that's a -1. Okay, so I am looking at a point that has a cosine of negative square root of 2 over 2. And a sine of square root of 2 over 2. What do you think is that angle? What angle are we talking about? You know. Oh, I need to give myself more room here. You guys can see that. What angle do you think I am going to talk about here? Okay. And the point, oops, that's awkward. There is as much as I can here. The point was -4, 4. So the point was here. -4, I'm sorry, at the top here. -4, 4. My point is here. What angle am I making with the x-axis? What angle is this? What theta is this? And I see an answer, and the answer is very true. The theta is the angle that you're looking for, Armani, is the theta is 135. 135. Remember, the powerful thing about what you are looking at right now, your eyes are beholding power. Why it's powerful? Because you are finding the angle from a point. And the point is not on the circle. It's not on the unit circle anymore. The point is beyond the unit circle. And because of the knowledge that you have of the unit circle, you're able to find points beyond the unit circle. So it's like like infinity and beyond, Buzz Lightyear, just like that, like really beyond. But you still can't find it out. Come on, we just did. Well, here's another one. This one says this example says find the trig functions of 4 square root of 3 and the corresponding angle in the interval 0 and 2 pi. By the way, the last one that we talked about, you gotta reject some stuff. The last one that we talked about, which is this, if you guys pay attention, if you are paying just a little bit close attention, you'll find out that 135, because of the point here, let me just a little bit here. This point, -4, 4, I mean, you could end up with a negative a negative cosine and a positive sine, if you guys remember, all students take calculus, right? So if you were to say, for example, this is all student take calculus. I need a negative cosine. Negative cosines happens where? Negative cosine happens here, but that's not gonna work. The only point that you see is the only option that you could tell here is just the second quadrant. You can't go for you can't match this point into other quadrants. You have a negative cosine. You might ask me, how about down here? That's a negative cosine. Yeah, but the sign is positive. That's why it has to force you to be in the second quadrant. Okay. Example number 3. Example number 3. It says that find the trig functions. We are only focused, by the way, on the sine, cosine, and tangent. The other ones you could just do the reciprocal. If you're in pre-calc and watching right now, you could do the reciprocal for the other ones: cosecant, secant, and cotangent. Okay, so now let's go back to the same process. You just have to think of where are you at in the unit circle. So here am I, and I'm gonna quickly put myself couple lines here. That's my unit circle, my beautiful. And then I have a point that says 4, 4 square root of 3. Interesting, I don't know. But maybe you could use a calculator to find this. It says without a calculator, by the way. But square root of 3, so this is between the square root of 1, which is 1, and the square root of 4, which is 2. So between 1 and 2. Maybe something. I don't know the value. I mean, I could look it up. But anyways, so this is 4 times something. Obviously, you're somewhere here, like somewhere probably here or something. 4, 4 square root of 3. Okay, you're somewhere here. This is your x, this is your y, and now you're asked to find again the trig functions. Well, I find the trig functions by finding the radius, the r. So I don't know what this angle is making. I don't know. I'm not sure what this angle. That's going to be my second request, my second and the corresponding angle. Just first, let's just find the trig functions. So following the what we talked about before, the r. So let's say, for example, r equals the square root of x squared plus y squared, and my r, this is going to be a little bit tricky, okay? R equals the square root of 4 squared plus I have 4 square root 3 squared. Are you serious, Armani? Yes, I am serious. I know this is 16. I know this is 16. But how much is that? Well, think a little bit here. How much is that? So perhaps you could help yourself by thinking. His thought, thinking. This is me thinking. Think. This is me thinking. Okay. Square root of 2. Let's say square root of 3 times square root of 3. Well, this is going to be square root of 3 times 3. Square root of 9. Or just 3. Okay. So don't forget that. So here, what you're saying here is the 2 is being squared, right? The 4 is being squared, and also the square root of 3 is being squared. Both of them are being squared. And if that is true, then this guy has to be 16 times the 3. Yeah, because square root of 3 times square root of 3 is 3. Okay, so that's what you do for this one here. So what is that number? Well, I don't know. I have to use a calculator for that one. So let's use a calculator for that one. And I am using the calculator. And I end up with 16 and 40. This is 48. 16 plus 48. So this is going to be 16 plus 48. Which will give you, by the way, a square root of 64. 48. 64. And all of you know that the square root of 64 is just an 8. So R is 8. R equals 8, okay? So now how to use this knowledge to help you find the trig functions? Well, I'm going to have to erase, okay? So I'm just going to put R equals 8 here. And then I'm going to erase this guy. Erase here. Back to the sine, cosine, and tangent. And that's going to be a little bit easier for us now, since you have a number. Actually, you have a number. And let's do, first of all, let's go with cosine. Cosine, theta, this angle here, theta, is going to be the x over r. Well, I know my x. This is x. This is y. X is 4. R, we just found R. It's here. It's over here. 8. Which is, by the way, it's going to give you 1 over 2. Cosine is 1/2. Interesting. Okay. Cosine is 1/2. Cosine is 1/2. Interesting. That makes me think a little bit. I've seen something like that before. Sine theta equals the y over r. And the y is here, 4. That's given. 4 square root of 3 over r, which is 8. Now your math ability would show up because you need to simplify. Simplify. Oh yeah, oh yeah, oh yeah. The 4 and the 8. That's going to give you a 1 over 2. Interesting. There's a 2 at the bottom. Yes, there's a 2 at the bottom. There's nothing wrong with that. That's going to give you a square root of 3 over 2. Very interesting. I wonder what could that be. Are you thinking with me here? I have a cosine of an angle that is 1/2. I have a sine of an angle that is square root of 3 over 2. I think I've seen something like that before. I did. Come on, I did. Y over x. And the y is 4 square root of 3 over the x. And the x is 4. The 4 is going to go ba-ba, ba-ba, ba-ba 4. That's going to leave me with a tangent equals to a tangent of, interesting, that's just a square root of 3. So let me just put the point in a format that I'm aware of. 1/2 square root of 3 over 2. Oh my gosh. Oh my gosh. I've seen this before. Here we go. I've seen some of you in the comments. Yes, yes, I know this one. This is 60. This is 60. What are you talking about? Yes, that's angle 60. Come on. That's angle 60. Okay? Remember, the powerful behind the powerful tool that we use to get to this point is this. These are points beyond, away from, far, beyond the unit circle, and you're still able to get the angle. Oh my gosh. Okay, I'm just saying. I just got excited here. I'm sorry. I shouldn't apologize. I'm excited about this. Come on, I'm excited about this. Oh, here's another one. Find trig functions of 2 comma negative 2 square root of 3 and the corresponding angle in the interval. Okay. First thing first, I'm going to use my tool, and my tool is going to be here, and I am going to see where does this do that. At least predict, because I don't know exactly what's going on, but I could predict, could infer a higher thinking questions. Okay. This is x, this is y. Again, the r excuse me, r is square root of, by the way, the square root of x squared plus y squared, that comes from Pythagorean theorem. So it's not like a magic I pulled it out of a hat or something. This is just a Pythagorean theorem. Because if you have a point, and you're just doing the x and y, you just find the r by Pythagorean theorem. I have 2 squared plus, be careful with the negative 2 comma square root 3 squared. I shouldn't say be careful, because actually you don't really have to be careful, because there is a square anyway. If there is a square, it's going to square the negative, which is going to give you positive. Excuse me. Well, that gives me a 4. Plus, if you guys remember from the last example, negative 2 times itself is going to be a 4. There's a 2, and I'm going to just show you with an arrow again. This 2 belongs to the negative 2 and belongs to the square root 3. Don't forget that. That 2 belongs to both of them. So back to here. So I've got negative 2 squared. This is 4. Be careful that you're multiplying, by the way. And then I got square root 3 times square root 3, which is just itself, 3. How about the negative Armani? Well, you have the negative times negative twice. Negative times negative, it gives you positive. Okay? So now I have myself, I'm looking at 4 plus 12. 4 plus 12 squared, 16. Which is 4, by the way. So R is 4. The point that we're trying to graph here, 2 comma negative 3. So it's somewhere, I don't know exactly what the angle, but I know it's 2 comma negative 3, 2 in here, negative 3 down here. So it's probably somewhere, it lives somewhere here. Somewhere. 2 comma negative 2 square root 3. Okay, so that's this point. And let me just, maybe it's just different color for this guy. Maybe it's here somewhere. I don't know actually. Somewhere here, but it's definitely beyond the unit circle. Beyond, away from, bigger than the unit circle. No problem. We got it. So what? We got it. Okay, so I'm gonna again erase because I need some room. So I'm gonna erase the R. And basically, I wanted to work out my 3 functions. So cosine. Excuse my throat today. I'm not sure what's going on. Theta. Cosine of that angle is going to be the x over r. And the x is 2. R is 2. I'm sorry. 2. R is 4. That's not 2. R is 4. Which is going to give me 1 over 2. Interesting. Cosine of the angle is 1/2. Cosine of the angle is 1/2. Blah, 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 blah. I'm thinking. Cosine of the angle is 1/2. Okay. Sine of this angle is going to be y over the r. The y of my y is negative 2 square root 3 over the r, which is 4. Take my ninja, fruit ninja. Chop, chop, chop. The 2 and the 4. I'm going to get a 2 at the bottom. Square root of 3 over 2 negative. Okay. Finally is the tangent of this theta is going to equal to y over x. Hello. And my y from the point, I'm just looking at the point here, negative 2 square root 3 over my x, just at the point here, 2. Fruit ninja, chop chop, choop, choop. And I got myself a square root of negative square root 3. Negative square root 3. Interesting. Okay, so I really have to think here. What was the angle that has that had this point here? So I have an angle that has this point, 1/2, comma, negative square root 3 over 2. What angle do you think we are talking about? What angle could that be? Look at that. Look at the comments. You guys are good. Yes, the angle that you're looking for is 300. Yes, that is very true. Very true. Comma. That is very true. And the reason is The reason is it's going to be down here, 300. It makes sense, by the way, because this is like 60 degrees down here, right? 60 away from your, 60 is a reference angle from the closest x-axis, and that's going to give you that 300. 300 is the is that smiley face or something? Yeah, I think so. 300 is the angle that you're looking for. Okay, now we're all jolly and happy. What happens if we have a weird looking angle? No problem. I'm gonna close with this one, okay? This one here. Oh my gosh, what is this? Well, we'll just find out. This is x is 5, and the y is 3, and we're asked to find the trig functions again, cosine, sine, and tangent. And I'm gonna start with basically I'm gonna put my angle, and it's not gonna be perfectly done, but we are as much as we can. 5,3 is probably somewhere here. If you guys have 1, like this is 1, remember, unit circle, 2, 3, 4, 5, and 1, 2, 3, somewhere here. Okay, somewhere here is probably this this thing, and let's see if we could able to find that thing. Okay, find 5, 3. Okay, first of all, I have to find r. Okay, so r equals, let's just put it here, r equals square root of, using Pythagorean theorem, x squared plus y squared. R equals, I've got myself 5 squared plus 3 squared. That's 9 plus, I'm sorry, 25. I'm thinking ahead. Plus 9. 25 plus 9 is how much? Hello, blue, blue. 25 plus 9. Well, it turns out to be that you have a not so friendly number, 34. It's okay. There's no problem with that. Okay, so what? 34. So square root r equals square root of 34. By the way, that's this distance here. This distance. Square root of 34. That's the distance here. Right? Once again, I'm just going to erase and then just do the sine, cosine, and tangent. Okay? So let's go back here and do the cosine. Theta of this angle is equal to x over r. My x is 5. My r is square root of 34. I rationalize that. You guys remember, top and bottom. You could do 34. 34. And that should give you, this should give you a 5. Square root of 34. This is the 5 here. Divided by 34. That's an awkward number. I know, but it's okay. There's nothing wrong with that. It's just the way it is right now. Sine, same deal. Sine of that angle, theta. This is a theta. Is going to be the y over r. And the y, I have 3 over this amount, square root of 34. Rationalize. 34, top and bottom, because you're multiplying by, why do we rationalize anyway? Because you do not want to have a radical in the bottom denominator. You don't want to have square root there. And also, you're not changing the value of the equation because you're just multiplying by 1. Notice this here. It's like this thing divided by itself is 1. You just kind of a fooling the system thing. So this is 3 square root of 34 divided by 34. Okay, tangent. Theta is y over x, and that's going to give you a 3 over 5, and I'm just going to leave it the way it is, 3 over 5. So now, what is this? What's the angle? I don't know what's the angle, but there is multiple ways you find this angle. You could use the inverse function in your calculator, which we've done last time, I think, lecture, I think a couple lectures ago, and also number 12. So check that back. So you all functions, or I should say, all all calculators have either second and then your trig function, like second cosine, second sine, or shift. Just depends on your calculator and manufacturer. So anyways, mine here is second. So I'm going to just pick one of them. Let's say, for example, I picked the cosine, inverse cosine. So all what I did to find the angle, let me just give myself just a little bit more room here. All I did to find the angle is I said to myself I wanted theta, so I'm going to say cosine inverse of this amount, 5 square root 34 divided by 34. Yeah, so I'm just asking the calculator, give me the angle that has this value. Give me the cosine that has this value. And I did that, and it turns out to be almost 30 degrees. 30.9, 30.96. Okay, so that's my degree that we're looking for. Okay, so even if it's not handy dandy, nice, good looking like the 30, the 45, or the 60, I am still able to find out the angle for any point beyond the unit circle. And that is powerful and exciting. Very powerful. Okay. Here's a quiz, as promised, always at the end. Find trig functions of negative 3, 3. So if you're looking at this one, I would probably ask you to, obviously, when you watch this again, you pause, work it out, because I'm going to show you the answers, obviously. So just a few seconds for you to pause. And the answer should look like this. You got 135 and 300. Okay? With this, we're going to close, as always, whole 1 minute of hope with Armani. Guys, I was in a prayer meeting yesterday, and I was concerned, obviously, and we prayed for small businesses. I know some of you don't own a business yet, but a lot of small businesses got impacted, obviously, by the pandemic, and small businesses are kind of the spinal cord of our economy. So please remember these. If you have somebody that you know who owns a business, tell them that we're praying for them, and for all of us, particularly those who are struggling in their small businesses. It's not their mistake, but God is trying to show us something through this. Perhaps we could depend on Him fully, and not on our intelligence or planning, but on Him. For us, however, maybe this is just a hope for the future, because there's always hope. As always, as we look up again, we look upward towards heaven, where our help comes from. God is going to help us. He's going to be with us. He's going to be with you through your struggles and challenges that you're going through. He will see you through it. He's done it before, and He will do it again. Okay? Take care of yourselves. Have an awesome day. You guys are awesome. Take care.